as well. Perfect. The floor is yours, Willem.
Okay, can you see the PowerPoint slide in front of you?
Yeah, I see a PowerPoint and I see Z64K.
Okay, excellent. Yes, anyway, yeah, thank you, Sebastian, for inviting me along to this meeting. Yeah, my name's William McCabe. I'm the author of Z64K, which is a Java-based application which emulates the Atari 2600, Commodore 64, Commodore 128, VIC-20, and Spectrum emulators. One of the unique features about Z64K is the Commodore 128 emulation with the DO3 register. It actually emulates a 2 megahertz bit quite well, along with the test bit, which I'll demonstrate a little bit later. It also has very accurate VDC emulation and has a Testbench UI, SID player, and assembler. Start off, the requirements for Z64K, first of all, you need to go to the website, which I'll just bring over. And you download version 2 of Z64K. Like there's a version 1, which is just there for archival reasons. But if you want the latest and greatest features, always download version 2. And I recommend using Java Runtime Environment 8 or better. Oh, it needs Java 8 or better, but I recommend using Java 8. Okay, optional. The jar can be just run as an executable, but I do recommend setting up a bat file, or depending what operating system you're using, use that equivalent. So I'll get straight to okay, so I'm starting fresh with a brand new install. I've already created the batch file. So I'm just going to start up and guide you through how you should initially set up Z64K. So once you load up, you're presented with a portal page, which you can choose which application you want to start. The first thing you'll want to do is actually go to Applications, Machine Monitor. And if you see this kind of mess here with the graphics, you'll need to go to Settings, Machine Settings, General, and enable OpenGL. Save it, exit, and that'll create the config file, which will save that setting for future use. So you only need to do that once. And that's usually required for newer systems. Older systems, you shouldn't need to do that. So I'm going to start up again. And the next step you want to do is actually set up the configuration. So settings, machine settings, and we'll go to global settings. So a lot of these should be self-explanatory. At the moment, I'm on display 1. So this is for the full screen setup. I usually like to keep the aspect ratio. So when you go full screen, you keep the aspect ratio intact. Of course, if you unselect keep aspect ratio, it's going to use the entire screen. Going straight to the next setting, like you've already seen this settings here where we enabled OpenGL. Just to confirm, the graphics are now fixed. You see there's no glitches now when I step through the cycles in the monitor. And I will come back to the monitor with some of the features with that. But for now, we're just working on getting the application set up. If you want to start the jar file in another, by defaulting to Commodore 128, Commodore 64, you can select that here as well, but I'll just keep it to Portal at this stage. And there's some other settings here you can tweak depending on what your system can handle. Okay, JInput is the next thing you might want to install if you have any gamepads for games. So if I go to controllers, at the moment you see gamepad is disabled. I do have a gamepad actually plugged into my machine at the moment. So you only need to do this once as well, install JInput. And all that does is install the library file here. So your operating system can actually knows how to communicate with your gamepad. Okay, moving right along. Keyboard mapping. This is going to be important if you're not using a US keyboard, like if you've got a German keyboard or some other keyboard, you can actually map your keys to match your keyboard here. So for example, if I select G, you'll see in the top corner here, an ID here. That's the Commodore 64 ID, which is KB_G, which is a Commodore 64G, and it's currently assigned the PCG. For example, I'm just going to assign that to W now, and you'll see that key's assigned W now. So if I push G on the keyboard, it's going to output W's. Because I changed the key mapping for W, W actually gets G now. So if I push G, or if I push W, it's outputting G's now. I'm going to set it back to the default. Like that's just an example like of how you do assign keys. Once you're happy with your keyboard mapping and you've assigned all your keys, you can save. And in the config, you'll notice there's a new folder here, keyboard, and the keyboard mapping file will be saved depending on your current keyboard, your system's keyboard mapping. Okay, language is self-explanatory. You just choose whatever language here. Like when Z64K loads up, it should automatically detect your language if available. Okay, media. This is for screenshots. I might actually go to the Commodore 128 emulation to demonstrate this. And go to the AT screen mode. So back to media. At the moment, I've got 1 by 1 pixels. So if I save a screenshot, 1 by 1, save. I'm going to save the 4 by 3 now, or that's using X as a reference point. X, save. And finally, Y. Screenshot. Y, save. So I'll show you the difference with the output of those. So if I look at the properties of the original one, you notice the dimensions are 800 by 285, which is all the pixels that you see on the screen. Like if I open that up, you'll see it's actually stretched quite a bit. It's not keeping the aspect ratio when it saves. These other two do keep the aspect ratio. And for the X, it retains the X dimension, but it will increase the height to match the aspect ratio or to keep the aspect ratio. And for the Y, the same thing, except for the Y this time. Properties, details. The height is the same as 1 by 1 pixels, but the X is adjusted to keep the aspect ratio. And Testbench, that's used just for internal testing, so I won't go through that at the moment. The next thing you want to set up, or probably want to set up, is the paths. So I'll just quickly go through this and set all this up. So program. The cartridge is used by both the Commodore 64 and the Commodore 128. All the others can be separate values. And the cartridge. And I'll also do the Commodore 128. And save. Okay, next thing, if you've got custom ROMs like Jiffy DOS, this is where you can set that up. First of all, you need to give the ROM set a name. Then you can start assigning the ROMs for the different emulators. So I'll just assign C64, C128, sorry. Won't worry about the VIC-20. And make sure you save, and then you'll see Jiffy DOS appear here. And those ROMs will be available immediately. So if you go to ROM here, ROM set, you can select Jiffy DOS, and for each of the ones that are populated, will automatically populate the device that ROM is actually for. So if I do a reset now, you'll see now that it's actually indeed using the Jiffy DOS ROM. The final bit of configuration, depending what your system you got, you might want to increase the buffer size for your sound if you're hearing like stutters with your sound. But for now, I'll just keep everything as default. Okay, the final bit of setup you might want to do before you start using the emulation is go to applications. Testbench is actually used just for internal testing, but if you want to play with that yourself, it's I'll just bring up the other slide. You can get the test programs from the Device Test Repository, and that's the link there. So I've already downloaded all those files, so I'll go to configuration and go to the location I've saved that locally. Need to go to test programs and the folder called Testbench within that test program folder. Open, and if everything goes all right, the status will change to installed, and you'll notice that you've got the tree structure here with all the tests that you can run on your emulation. It does support other emulators as well, Testbench, as you can see there. But, yeah, I won't go into much detail there, being mindful of time. And for now, I'll just exit. And the final one to set up now is for SID Player. So I've already downloaded the latest high voltage SID collection from the following website. So I'll configure to point to where I've downloaded it locally. C64 music. And once again, the status will stay installed if installed correctly, and exit. There are other settings you can change depending what you like. If you want to start with 8580 emulation instead of 6581, you can select it here. Your VIC type, CIA type, and a whole other features. But for now, I'm going to close the emulator to make sure all those settings have applied. And we'll restart now. Yeah, one thing I will say, like with these machine model settings, you can do a hot switch of the different standards. So like NTSC, you don't need to do a reset. It will actually swap straight away. Same with power, with your SID emulation. So everything can be hot switched here. All right. All right, I'm going to go to the Commodore 128 emulation now and just show some of the features that are unique to Z64K. If I set Z64K to fast mode, the C128 emulation to fast mode, 6,1, you'll actually see garbage on the screen exactly like it does on real hardware there. So I'm going to open up Testbench just to quickly open up one of the test programs I actually contributed, which is called DO3 Tester, which is available on the test repository site, which I gave the link before. What this program does, it actually tests the DO3 register, and you can do some pretty funky things with the DO3 register, like actually move the Commodore 64 screen up and down. Like this is only in Commodore 128 emulation, and this has been tested on real hardware for this behavior as well. This text here is actually in 2 megahertz mode as well. So that won't display unless the DO3 register is actually implemented. Down the bottom here, this is the test bit, the test register test and DO3O. And you'll notice that you've got additional colors down here. So that's like the real hardware as well. There's a demo I'm going to show shortly that actually exploits this feature. I'm sure most people know about it, risen from oblivion from Crest. I think I might be going a bit over time, so I'll make this quick. So I'm just going to fast forward this now. So all these features you see require actually the DO3 register to actually work. So all these tricks are actually relying on what the 2 megahertz mode puts on the bus. Just quickly skip past this. Yeah, one of the things you can do to actually speed things up as well, you can disable the sound chip here, which will, when you're in fast mode, speed things up. So I'm in warp mode at the moment. I'm just trying to skip past as much as I can. to get to a trick that actually uses the DO3 test bit. So you'll notice there's one little glitch here, which I'm still working on fixing, but pretty much the DO3O register is completely implemented. And the final trick. Yeah, you notice this demo actually uses the full screen, and you'll notice there's actually a color switch with the bottom image down here. That's caused by the DO3 register as well. There is it. All right, I've got better move right along. All right, the next feature I want to go about quickly is some of the features with the machine monitor. For this, I'm actually going to start this in the command prompt. So command prompt will always override what you have in your settings. So how I'm starting the emulation is using Z64K BAT, starting in C64 mode. I'm actually starting with mon commands here. If I can open up the mon command. I don't know if you can read that, but like what's contained in that mon command is add a label at DE00 called IO test. It's going to set a breakpoint at DE00 and then exit. And what this test program is going to be running in the IO range. So I'll start it. And it's set a breakpoint, it's triggered a breakpoint. And what I'm demonstrating here is on the bus, like the disassembly window will actually update depending what's on the bus. So at the moment you see load Y AC01. So it hasn't actually retrieved the correct value from the bus yet. So if I do a single step, it's got the value off the bus and it's dynamically updated that disassembly to the correct value. So as you can see, you can single cycle step through using the disassembly window. If you push help, you can see a lot of the commands there. So I won't go to them in detail. I've been trying to be mindful of time. I think I'm going way over. And exit out of that. Okay. All right. Next thing I want to quickly demonstrate. I won't have time to go through all this. Yeah, some of the more the settings, like you've got your cartridge ports here. So I'm going to demonstrate. Oh, actually, I don't have time to demonstrate that now. What I did want to demonstrate is the user port. Like you've got the RS232 emulation. So for the TCP servers out there, like you can connect via putting using this address here, but disable internal modem if you want to connect to an external modem. But for now, I'm going to use the internal modem here. retro turn. So what I'm using here is retro BBS. Retro BBS and retro term version 3.01. So you can like download your own from there. Like I've got a local version of the BBS on my system, which I'm quickly going to demonstrate. Just going to enable echo there as well. Yep, so that's just your standard BBS you can connect to. So I won't go through too much through that. Exit. Yeah, Sebastian, how am I going for time? I'm being mindful. I'm probably gone way over.
Yes, you're a bit over. That I mean, that's not an issue. You know, it's a meeting for passionate people and by passionate people. So that's perfectly fine. I mean.
Yeah. Okay. Then, like, yeah, because I think I've got a lot more material than I realised how long it was going to take. But I'll persevere. I'm just rushing things now. So. Yeah, actually, I might finish up there, like just because I'm going way over. So I might open up to questions if anybody's got questions on.
I've seen some things passing by. Let me see. Okay, Eduardo says, I didn't have enough time to get the whole Java download path. Okay, maybe please share if time allows. Maybe what you can do, Will, is after is if you can copy all these links into the chat.
Yeah, I'll do that. Yes.
Then we have them there, and then I can also share that on the page, on the Commodore user web page, when probably in the coming days, when I will post the link to the video as well.
Yeah.
Then it says, how about Commodore graphics keys? Z64K has graphics key possibility on keyboard mapping. I think you showed that, right?
I did. I'll just bring that back up again. Hang on, have I still got it open?
Support for paddles as well. You showed, you demonstrated how we could actually configure and adding a gamepad. Gamepad meaning paddle, if I'm correct.
Yeah, that's correct. So like just a joystick. So
yeah,
hang on, where's mine? So that's what I'm using connected to my computer. So if you've got one of those connected, yeah, you can use it to play games. So yeah, here's your keyboard mapping. So yeah, like you got your Commodore key there, you can map as well. Like, yeah, I've had a lot of requests how to map keyboards over time. So this is pretty much where you do it at.
Yeah. I think I was referring to these graphics keys, these that you get on the side of the keyboard. You know, these.
Like if you push Control, like
yes, exactly.
Yes, yeah. So yeah, so yeah, on the real Commodore 64, of course, you push the Commodore key for that, or you've got you can change colors as well. So you get the hint from actually going to this keyboard. So here I've got the Commodore key assigned to the Control key. So if I wanted the special characters, I'll push Control and then the key with that special graphic on it.
Mm-hmm. Looks nice.
I did want to show just one last thing that I think is unique to Z64K. If I go to the model, there's a drive GPU here. What I'm going to load up is a program called FreeSpin. Which I've got the link for that here as well. So I don't know if people remember seeing this demo late last year, but what this is, it's a demo that just runs completely off the disk drive. Like, you use the computer to actually load the program onto the drive. And once it's actually loaded, you can actually disconnect the computer. So I've disconnected the computer there. And to get the demo started, load drive 8 again and just reload the same disk again. So this particular program runs completely off the disk drive. So you can follow that link, which I'll send later, which shows how that actually all works as well. But yep, on that note, I'll leave that there, and yep, I'll just leave it open to questions, and I can finish my presentation if you're happy with that.
Yeah, I have actually a couple of questions. So now we saw that it was running on Java runtime version 8, but you're demonstrating this on Windows. But so I suppose it's really just, it's not system dependent. It's Java runtime dependent, right?
That's correct. I've had it running on a Raspberry Pi. Of course, it doesn't run full speed on a Raspberry Pi because it actually does need quite a well-spec'd computer to run on, but I have run it in Linux, and I know people have run it on Macs as well with no problems.
Okay, and it's quite the configuration. If I followed correctly at the beginning, so it's quite modular, right? So you can actually import what you want, like you showed the example of this of the gamepad. So by default, it doesn't come with it's not configured to handle the gamepad, but then you go into the configuration, you select, and then it's this additional module is installing.
Yeah.
Okay, and you had then different version there, 64, 128, but I saw VIC-20 as well.
Yes, we've got VIC-20.
Perfect. Okay.
So yeah, the reason for creating the VIC-20 was for the VIA emulation, like, because it's got quite a few good test programs there. People have asked me, why the Atari 2600 as well? It was a system that actually uses the ready pin of the 6502, which helped with that, like with the VIC ready signal, and also the ZX Spectrum. Why the ZX Spectrum? Z80 emulation. So the Z80 emulation is pretty much 100% accurate on the Commodore 128. It passes ZEX all in addition to ZEX doc, if people know what those particular programs are. And they all should be cycle exact order commands as well for the Z80. And one of the bit of a connection with the Commodore 64 with the ZX Spectrum emulator, if I go to settings, you can actually have a SID on the ZX Spectrum as well.
Okay. Today we skip to we stick to Commodore.
Yeah. Like I thought so. That's why I was leaving those ones around.
No, that's why I was referring to the VIC-20. Actually, I have interest in that one as well.
Yeah. So the VIC-20 NTSC also has interlace emulation implemented as well. So some of the demos by Tokra will actually work in NTSC on the VIC-20. So yeah, something worth checking out as well.
And I saw you started working on that in 2014. I saw somewhere you had 2014, 2021.
Yeah, that's correct. Started in 2014. The whole purpose was initially to start teaching myself Java, and the project just started getting bigger than like I originally planned, and that's where it is today. Like it's always like once you kind of start studying one thing, that leads on to something else, and yeah, it's been a great project, and it's been a great collaboration with the community as well. A lot of the features have been in collaboration with the community with feature requests. Excellent. So if you got any feature requests, yeah, please reach out.
Good to know. Okay, perfect. Thanks a lot, Will. I see nice comment, people making a thumbs up and impressive, cool, nice, perfect. So I will then stop the recording now. Thanks a lot again.
Yeah.
If you can then post the link somewhere.
Yep, I'll do that.
And then I don't know if you stay around, then maybe more questions will come up. I don't know.
Yep, I'll hang around if there's any more questions. So,
perfect.
yep.
Thanks a lot for that. So I stop the recording.